I have started recording. Okay, Andy, maybe we can start with you. The subject is quite hot. DP-600 exam preparation. These people are the most talented, most experienced people in the world that you can follow. Please follow them. They follow their LinkedIn accounts, YouTube channels, their blog sites. You will learn a lot, definitely. Okay, Andy, would you like to start?
Yeah, let me share my screen. And then let me know when you can see it, okay?
Yes.
All right. So I think there's quite a few of us. So I'm going to be talking more about the about Fabric itself and the introduction to the exam. And then afterwards, all of the truly talented people can come in and start actually telling you what you need to know in those parts of the exam. So I'm just moving my teams over to over there. So I've got my mobile phone in front of me. So if any of the team want to ping me on WhatsApp if there's a problem with my audio or video, let me know. But let's go. Well, Halil, thank you very much for inviting us all back on again to talk about another certification, the DP-600. So this is a very popular certification if the stats from Microsoft are to be believed. Thousands and thousands of people have engaged with this certification, which is really, really good. So this is DP-600 Fabric Analytics Engineer Associate Certification Prep for the Microsoft Fabric and Power BI Turkish user group. So a bit about me. My name's Andy Cutler. I work for myself, Data High. So my company's at datahigh.co.uk, moving quite a lot into Fabric, technical delivery and assessments, architectural designs, and low-level work and support there as well. I blog personally from a community perspective at Serverless SQL, and that QR code will take you to my link tree where it's got YouTube and various other social links on there as well. So we're going to be talking about Microsoft Fabric to start with, and I will ask my host to keep me honest in terms of the time.
Sure.
But really, we're going to dive in. Okay, so what's Microsoft Fabric? We've got multiple workload types now available to us in a common interface that data analysts, data engineers, developers have come to get familiar with and know over the last few years, which is Power BI. So now we've got Data Factory, we've got data engineering workloads, Spark, etc., warehousing, machine learning, and data science. We had a little bit of that with Power BI, but now this is at much more of an enterprise scale. And we've got some real-time streaming workloads in Fabric as well. Yes, there is Copilot across all of those services in some shape or form. So work with the warehouse service and write T-SQL, work with data engineering, and it helps you write Spark and Python. Underpinning that is the logical data lake called OneLake. So all of these services in some way use OneLake to store data. And we've got some purview integration as well. So we've got some governance across the services. We can see who is doing what and where. So ultimately, what that means from an architectural perspective is that you can bring in all your different sources from third parties, from other Azure services as well. Use the relevant workload. Could be T-SQL in warehousing. It could be Spark and Python and Scala within data engineering. And we can bring all that data in, process it, store it, and deliver. So really what we're looking at with Fabric is a SaaS platform. It's software as a service. It's yet another degree of separation away from platform as a service. So all those Azure services like Synapse Analytics, Azure SQL Database, they're all platform as a service. You've got some control over how you configure that platform. With software as a service, essentially you're relinquishing some of that control to Microsoft. Microsoft are looking after it for you. Whole lot of benefits there. Some drawbacks as well. But essentially, Fabric's giving you a whole suite to be able to store data, to process it, to load it from different systems, to build models, and to report, all in one platform. I think what has been pushed quite heavily, and I've started to get into quite a bit, is the real-time aspect. Lots and lots of different ways of bringing data in, Data Factory, Spark, so on and so forth. But with the real-time functionality, we can connect to streams from outside, we can bring it in, we can process that data, we can land it downstream. But from an overall platform perspective, what Microsoft are doing, because this is software as a service, you provision essentially one service and then use the different workload types in your data platform and in your architecture. What you're not having to do is connect all of those disparate services in Azure, for example, that you would need to deliver a data platform. So storage accounts, any kind of Spark-based compute, SQL databases, credentials in Key Vault, could be machine learning. All of those services have to be connected to each other and all of the different security mechanisms between that. So within Fabric, we're looking to remove that pain, bring everything together into one service. And what does underpin everything is one lake. It's this logical data lake. It's essentially built on Azure Data Lake Gen 2. It works with those APIs. So those tools and services that can connect to Azure Data Lake Gen 2 can also connect to Fabric OneLake. So things like Azure Storage Explorer. And those services, Data Warehouse, Lakehouse, Real-Time, they will use that storage. And those services can then talk to each other in terms of the data. Now, when we talk about the integration of various workloads, there are a lot here. So we've got Power BI, data engineering, data factory, data science, warehousing, the real-time intelligence, and that includes data activator, i.e. responding to events in real time. Industry solutions, so these are the patterns that you can employ from different industries. Retail, I know Kevin Chant does a lot on the sustainability side of things. These are templates that you can use. And hot off the press in private preview is now SQL databases. So now you can bring in some of your transactional workloads into Fabric as well. So maybe there's a shift into more of a total integrated data platform than just an analytical platform. So just diving in to some of the aspects of Fabric itself. So with data engineering, we're looking at Spark. Okay, so essentially notebooks, writing PySpark code, Python, Scala, loading data, processing data. So you're thinking data frames and delta tables, but with an eye on large scale data processing as well. So any scale really, you can create small clusters, you can create large clusters. We can integrate that with Data Factory. So we can create pipelines to orchestrate our Spark data engineering workloads. So we can trigger different notebooks at different times and parameterize. So if we're Spark engineers, the Fabric's got you covered there. So we've got data warehousing, so the T-SQL based service. So this is, to all intents and purposes, Microsoft's proprietary SQL data warehouse service based on a product that's in Synapse. And this any data size requirement is quite important. So when you see any data size, you think large scale. Well, yeah, it can handle large scale, but it can also handle small scale data as well. So it kind of fixes the any data workload size that there is in other cloud data warehousing systems, where they only really come into their own at massive amounts of data. And yes, we've got separation of compute and storage. The storage is Delta. It's in Parquet. So we can store data in those formats in the warehouse. We can read that data from other services, the Lakehouse, anything that can read Delta, the data warehouse service will expose that. And when we look at real-time intelligence, so we've got a suite of products within Fabric in which we can connect to outside sources that support things like Kafka, event hubs, ingestion services in which events are being posted onto. We can create our own endpoint within Fabric as well. We don't actually need these outside services if we don't want them. And what we can do is stream data real time into data storage, into our event house. And we use languages like KQL. So we can set up data ingestion and processing policies with KQL. It's got some visualizations out of the box as well. So you've got both Power BI visualizations and the real-time stuff. And on the data science side of things, so we integrate machine learning workloads. Again, there's Spark, there's PySpark. You can load in any library that you want to use with machine learning, build models, score those models, and train those models, and have them available for services to use to integrate your operational analytics, your anything you want to do with machine learning. So in the exam itself, and Halil, how long have I got? About 5 minutes for this, do you think?
Yes, more or less
Yeah.
5 minutes. Yeah, 7
5
exactly.
minutes. Yeah. I don't want to take anyone else's time. So the crux of this certification is around analytics engineering. So we kind of need to know, well, what is analytics engineering? It occupies a space within the overall data processing pipeline. So it's not all of it. It's not the big bit at the beginning. It's not the bit at the end. It's the bit in the middle. Are we responsible, or are analytics engineers responsible for getting raw data? Nope. Are they responsible for putting reporting together? Nope. The bit in the middle, the big bit. There's a great big chunk here. Defining data rules for cleansing data through to modeling that data. So that could be, and I'm going to say any data modeling technique, dimensional modeling, for example, my personal favorite. Then building semantic models. So then starting to extract that data, model it, and build it into a business facing model in which then analysts and report developers can then use to build reports for the business. Now, that analytics engineer might also be responsible for training people in how to use that semantic model for reporting. So when you're looking at what you're likely, or what your responsibilities in your role is, or if a company is looking to integrate analytics engineering into their processes, is that we're preparing data for analysis. We're maybe looking at managing those assets. So we've got some security around how we put the semantic models together, for example, how we're building those models, right? So how we're going to load the data from the services into our semantic models. What settings do we need to know in terms of managing large semantic models and the licensing requirements around those? But look, there's some integration with the business as well. So as an analytics engineer, you'll have to work with the business, and you'll need to work with the business to understand what data you need to transform and how the business want that data transformed. You need to then go away, work out the best way of doing that. But also, how do you query those data stores? So if you've got data warehouses, if you've got lake houses, how are you querying those sources to get what you need out and in the correct way as well? So overall, in terms of that focused subject matter expertise, you're going to be designing analytical assets, so semantic models. You're going to be looking at managing data warehouses, reading data, creating semantic models, and handling lake houses, so connecting to and querying lake houses. Not necessarily building the structures within the warehouse or the lake house, but working with them and reading from those objects. So the last slide here is the exam breakdown. So there have been some changes that will be talked about in this session due to the fact we've got a new exam, the DP-700, the data engineering with Fabric. So some aspects have been moved around, removed from DP-600, added to DP-700. But in terms of the skills being measured, and this is what we'll go through in this session and is available for download from the certification webpage, is, well, firstly, managing or maintaining a data analytics solution. So that's the top level. Preparing data, which is half of the overall certification. So if, I don't know, the average exam is about 50 questions, or 50 or 60 questions, you're going to be looking at 25 to 30 questions dedicated to preparing data and then implementing and managing semantic models. So a good quarter or a third, again, dedicated to how you build semantic models and all of the ways and means that you'll do that. Large model, relationships, so on and so forth. Because, hey, as an analytics engineer, that's going to be the result of all your hard work, is going to be that semantic model that then gets used downstream for reporting. So I think on that, we're ready for the next part.
Brilliant. Thanks very much, Andy. Let me just share my screen. Can you hear me okay?
Perfect.
We do.
Okay, awesome. Thanks very much, Halil, for inviting me to speak today, and to Andy as well for that awesome introduction to Fabric and the exam. So for those that don't know me, I'm Will Needham. I make some videos about Fabric, trying to teach people how to use different parts of Fabric. And I also manage 2 communities focusing on training, helping people, again, learn Fabric. So I'm going to be introducing you to Module 1, as Andy just introduced there, maintaining a data analytics solution. And Heini will also be joining me for the second half of that module as well. And in this module, it's worth 25 to 30% of the exam. So it's a fairly decent chunk. And in this section, you can expect questions around these topics, right? So these are the skills that are included in these sections. So it's broken down by implementing security and governance, and then maintaining the analytics development lifecycle. So we haven't got too much time, so I'm going to just jump straight in with our first topic. Now in Fabric, when we're dealing with administration, you have to really think about the different levels. Now, I like to think of this as a bit of a hierarchy, right? So at the top, you have one tenant normally in most organizations. And then as you go down a level, you have one or more capacities. This is where you buy a Fabric capacity at a particular SKU, stop keeping unit. And that determines the amount of compute resource that you have available to you in your organization. Then you have the domain level. This is becoming more and more important in the world of Fabric. There's more and more settings that are being delegated through that domain level. Then you have the workspace level. Obviously, the workspace is the grouping of different items. That's where we create our data warehouses, data pipelines, that sort of thing. You also have the item level, which is kind of one level down. So there's settings of administration that we can do at that item level. Then we go even further, even more granular. We can do things at the object level. So individual tables in a data warehouse, for example. And now we can also do things at the file level. So in a lakehouse, the lakehouse is basically a set of folders and files. And now with a new feature, we can share just folders or just files. And we'll go through that in a bit more detail. Finally, we've got row level. So within a table in a data warehouse, we can drill in even more and set security rules around the row level and for specific columns as well. The top half, you don't need to worry about for the DP-600 exam. So this is one of the changes that was made recently. Previously, kind of all of these levels were assessed, but now the focus is just on the workspace level down, right? So that's what we're going to be focusing on here. So let's start with workspace level sharing, right? So we can share a workspace with a user or an M365 group or an Entra ID security group as well. We just go to the manage access in the top right there, and we can add in our user or group, and we're going to assign them one of these 4 roles: admin, member, contributor, or viewer. Now this role applies to all of the items in the workspace, right? So if you give someone the viewer role, they'll be able to view everything in that workspace. Now, one table that's really important to understand, because this is a very common source of questions for the DP-600 exam, is this one. You'll find it in the documentation there. You can just search for workspace level or workspace roles fabric. You'll find it very quickly. I definitely recommend going through this and understanding, this in detail. We've got all of the capabilities, things you can do in a workspace. And on the right-hand side, you've got those roles, right? So admin, member, contributor, and viewer.
Eğitimdeyim.
So the admin can do everything in a workspace. The member can do nearly everything, but they can't update or delete the workspace, and they can't add admins, right? Contributor is a very common role for people. You can basically create or update most Fabric items. You can't actually create a warehouse or a database mirror as a contributor. Something to be aware of. And then viewer, the important thing to be aware of is that you can obviously view things, you can read notebooks, but you can't execute them. You can't execute data pipelines anymore. And if you want to view data, you have to do it through the T-SQL endpoint for both the Lakehouse and the data warehouse. You can't use any of the Spark, the Lakehouse Explorer, or the APIs or anything like that. So let's shift down level into that item level now. Because if we don't want to give people access to everything in a workspace, we can do this item level access, right? So I just want to share this data warehouse. And why is this important? Well, we've got this principle of least privilege. So you might get a question in the exam saying, keeping in mind the principle of least privilege, and you have to understand what that means, right? So what we mean by that is that when we're giving access to users and groups, we're only going to give them access to the data or the items that they need to perform their jobs, basically, and nothing more, right? So if people don't need access to everything in the workspace, perhaps we don't give them access to everything in the workspace. We just share the things that they need. How do we do that? Well, you can right-click on nearly every item in Fabric, apart from data pipelines and data flows. They can't be shared at an item level. Everything else can. And you get a box that looks a bit like this, right? So this is the data warehouse example. And you can see there's a few different settings that you need to understand for the exam. If you don't have any of these boxes ticked for additional permissions, you're going to give them read permission, which means they'll be able to navigate to the data warehouse via the OneLake catalog, as it's now known. But they won't actually see any data in there. They won't see any tables. You might ask, well, what's the point in that? Well, it's useful for when we configure OLS, object level security, column level security, which we'll get to in a minute. But it's likely for most use cases, you're going to want to give them at least some additional permissions. So read all data using SQL will basically open up the data and the tables in that data warehouse for them to query with select statements using T-SQL. The second option there is read all OneLake data, right? So with this option, you're allowing them to query the data in these data warehouse tables using other engines, right? Using the Spark engine, using data pipelines, using the API, any other way that you can access the actual underlying OneLake data. And the third one, just going to allow people to build reports from the default semantic model. So one of the changes recently about the November the 15th, there's more of a focus on actually implementing row level security, column level security, object level security. Before you just kind of had to be aware of it. Now you need a bit more hands-on. How do you actually do this? So we'll go through these quite quickly. First things first, as a prerequisite, you need to make sure they have some sort of access to the table that you're trying to give them row level security on, either through the read data permission, as we just went through, or you give them object level security for that specific table as well. 3 steps. First one is optional. Creating a schema, sometimes called security. These are just to group the things that we're about to create and make it a bit more tidy. You're going to need to create a function. And this function is basically just filtering your table based on the logged in or the person performing the query's username, right? So that's where sales rep equals username here. Or is role member is just a bit of a utility function here that means that as a manager, you can also view all the rows. Finally, we're going to create a security policy, and we're going to add in what's called a filter predicate, which is basically just pointing to this function that we created. And then we're assigning it to a specific table, in our case, on sales.orders, with a state of on, right? So this is just a bit of boilerplate code that would be worth working through. A few examples in your own Fabric environment, I recommend that. For OLS, so object level and column level security, you need to assign the user or the role a read permission to the warehouse, right? If you remember, read permission was no additional permissions. So you're basically giving them the base level of security, and then you're going to individually give them access to specific tables, right? So you're basically giving them access to nothing, bringing the access right down, and then picking and choosing individual objects. To do that is quite simple. You can do a grant select. This is the object level security on a specific table to a specific role. CLS, column level security, is very similar. You can do a grant select on a particular table, pass in the columns that you want to give them access to a specific role here. Now, all of these can be done in the data warehouse or the Lakehouse T-SQL endpoint. This one, we're going to switch over to the Lakehouse, right? And specifically, we're talking about files and folders in the Lakehouse, because that is basically what a Lakehouse is. It's just a collection of folders and files. And we can use this feature called Manage OneLake Data Access. You'll see it if you're in just the Lakehouse Explorer. You'll see that. It is a preview feature, but it is listed in the study guide, so it's worthwhile knowing how this works. And it works conceptually quite similar to how it works in the T-SQL world. You're going to define some roles, add your users or groups to the role, and then for each role, you're going to specify which of these tables, like Delta tables in your Lakehouse, and files you want to give people access to. To configure this, you're going to need to be a workspace admin, member, or contributor. So just to round off this first section, I just want to talk about a few data governance features, specifically sensitivity labels and endorsement, right? So you might have seen these sensitivity labels in items that you're working in Fabric. The labels themselves now need to be created and managed actually in Purview before you can actually access them in Fabric. So this is a slight change from how it was a few months ago. Before, you could actually do this without Purview, but now I believe you do actually need to set things up in Purview before they become available to you in Fabric. And typical labels will be things like confidential, right? It's an information security, information protection feature, this, necessary for compliance in a lot of industries. Endorsement is another feature. As you can see here in the bottom left, it might be a bit small, apologies for that. We've got 3 different categories for endorsement, right? We can promote something, which is basically recommending it to other people in your organization, saying, yeah, this is pretty good. Certification, which is a bit more of a level of guarantee of quality. So normally this would be aligned to some sort of organizational policy or standard saying, okay, this lakehouse meets these particular standards for example, data quality or validation, something like that. That's very much up to your organization to define that. And the last one is fairly new, is master data, right? So if you're practicing master data management in your organization, it's basically saying that this is the single source of truth for that particular data set within your organization. That's everything from the first section. I'll hand you over to Heini, who's going to continue with analytics development lifecycle.
Great. Thank you, Will. And just to verify, can you see my screen now? Yes, great.
Yes.
Excellent. Thank you also to Halil for having me over here today. I'm really excited to get to talk about this particular section of the exam. So I'm Heini. I'm coming from, as you can tell, it's quite dark outside already, over on this side of the globe. What we're going to be talking about in this section is we're going to be talking about everything in relation to deployment, meaning version control, deployment pipelines, everything that makes repeatability easier for you when you are working with Fabric. So we're going to get started on this side by talking about version control first. So, and when you set up version control, you set it up at a workspace level. So you're able to take whatever source control system you have and link that with the workspace that you are working with in Fabric. So you would go into your workspace settings and there's a Git integration section there where you can set this connection up. To be able to work with Git efficiently, it does mean that you have to familiarize yourself a little bit with kind of Git concepts and know what are like the basic things in the Git world. How do you create branches? What does that mean? What are commits? Those are when you put your change in there, pull requests and merging. It really helps if you can kind of get up to speed on those topics as well. Even they are not maybe specifically covered on the exam, but the topics relate to all of those concepts as well. There is a few supported Git providers. So at this time, it cannot be whatever Git provider that you are using, but we had Azure repos from the very beginning. There is a limitation that it has to be in this or be linked to the same tenant as your Fabric is in. So you need to kind of ensure you have access to the same Entra ID users in both places. We can also use GitHub as a repository to store our code, and that includes GitHub Enterprise as well at this point. So I think that covers, at least from the Microsoft perspective, all the most important repositories, but of course it might be that you are using something else, and at least at this point, those are not supported. And when you set up the Git integration, you kind of get a nice view of your items in your workspace, whether they are synced with the Git repository that you have set up. That means that they are already covered there. It could be that something is uncommitted, so there is a change that you have not taken to Git yet. And then it could be that you see this unsupported text as well. And that just is referencing to the fact that not all items are yet supported. So actually most items are still in preview and only the notebooks are GA. So I think we are very much waiting for some improvements on this side still. So if you kind of think about the setup, you have your Fabric tenant, you have one of the supported central repositories in place that you want to use. When you set up that connection between your workspace and the repository, you get some functionalities that you are able to leverage. So essentially, you take one of the branches that you have in your repo and link it to your workspace. One of the things that we can do is that we can branch out to a new workspace, and that means that it essentially makes kind of a copy of your workspace that you have. And on the other side, at the repo side, you get a feature branch that you can then work in. There are kind of two ways we can synchronize with the Git repository that we are linked in. So we can either pull the content from Git into our workspace from the branch that we are linked to. That would mean that if we have some changes in our workspace that are not in Git, those will get overridden. So we should keep that in mind. The other option is that we can go the other way. So if you have made a change in your workspace, you can then commit that change to the branch that you are linked to from your workspace. And through kind of looking at these, you can have your development processes in a place in whatever format you would like. I'll have a link later on to some samples of how you could approach this. And in this area, you really need to think about what are the supported items. And there is also some specific permissions that are required to be able to actually work with a Git integrated workspace as well. So pay attention to those. We kind of hop into a slightly different kind of topic here out from the version control exactly, but it is somewhat related. So we go more to the Power BI report side and specifically Power BI desktop projects. We need to know that this is in preview, so it actually needs to be enabled. On your Power BI desktop, you need to go in and tab it on for yourself. So what this does is that it creates these report and semantic model item definitions that are saved in a specific folder structure. And all of the aspects of that report and semantic model are in this kind of readable text files, which means that you can use a text editor to modify them. They can be version controlled and so forth. And you are able to take your kind of existing Power BI project and you are able to save that as a Power BI project file. And this is kind of the layout that you then get for the associated files that relate to it. So you get this PBIP file, that is the actual report file. And then you get this report folder and then the semantic model folder that both have their own structures. And it's at least good to be familiar at a high level of what do those contain and how do these work together to kind of have that complete setup for yourself. And the semantic model portion of it, that can be either in the tabular model scripting language or the tabular model definition language. The TMDL is the newer kid on the block, but it's very much kind of set up from the ground up so that it is as easy as possible for you to author those. So that is definitely, I think, the way to go in the future, and it is also better suited for version control and tracking changes and so forth. So what changes in that case? The model BIM file gets replaced by this definition folder and everything that is in there. So it is much easier to work with when you are making changes. Then we'll kind of hop back over to the Fabric in general. So we did a little hop over to the Power BI report side there, going through the requirements. The next item has to do with deployment pipelines. And this is kind of the visual of what it looks like in the Fabric side. When you create a deployment pipeline, you set up these different stages and you link a workspace to each stage. And then at each of the stages, you will see whether there is a modification, if something needs to be removed, or of course, if something is completely new and needs to be added. So it's kind of this intuitive UI that you can use to create your deployment process. Where do the changes go from between the different workspaces that you have in place? And essentially behind the scenes, the deployment will actually copy the items to the new workspace that you have as the next stage. Or of course, if something gets deleted, it will delete the item from the workspace. So for example, a typical deployment process might have these different stages that you have a development workspace, you have a testing workspace, and you have a production workspace. And then you have those different stages representing each of those stages associated with their own workspace. You might also come across this notification, as you could have in the Git side as well, that there are some unsupported items. So that just means that those do not get copied over. So one of those examples is the data flows Gen 2 that is not yet supported. And actually kind of your full deployment process could include both Git integration and deployment pipelines. So depending on your organization and how many developers, that could be something that affects the entirety. And there's quite a good documentation about the options. It's unfortunately, I think it's a good documentation, but it's very high level. It might not quite give you the tools to actually implement it in practice, but it's a good place to start. And then for the deployment pipelines, because between the different environments, you might have some different parameters, or you need to link to a different lakehouse, for example. So you can have these deployment rules in place that take care of that for you when you do the deployment. It doesn't quite yet cover all areas, but some of the most common ones at least are supported. As you can see, we're going through this quite fast. We're moving on to impact analysis, and how this relates to deployment is when you are making some kind of change, it will probably impact some other services within Fabric as well, or some other items. So what this helps you to do is determine how will your change impact others, or whether it's within your team or some other part of the organization. So you can get to this by using the lineage view, and then there's this weird little icon at the corner of each of these boxes, and that opens up the impact analysis box for you, and you can see kind of what are affected, and then you could actually get from here to actually reaching out to the people who own those and sending them some information about the upcoming change as well. And we'll keep going. There's a few more things to go through here. We are moving on to semantic model deployment and management using XMLA endpoints. So the XMLA endpoints work so that they enable you to connect with Microsoft tools as well as third-party tools as well to the semantic model workloads that you have running in Fabric. You can kind of think of it, you have kind of your model defined, for example, using a star schema, and you have that semantic model. Then you have this XMLA endpoint available that you can communicate with. We'll talk about the read-only versus read-write in a sec, but one thing you need to remember is this is only for the premium capacities and embedded versions, or the premium per user also works. So it's not available for everybody. We are in the premium world here to be able to use this. So the XMLA endpoint has a read-only mode or a read-write mode. The read-only mode is the default, and that of course means that you are able to read the semantic models and things like that. But if you are going to deploy or manage a semantic model, that's not quite enough. So you would have to enable the read-write mode to be able to do that. And that, of course, then enables you to manage and do some more advanced things to your semantic model as well. And there's like multiple tools that you could use here. There's, for example, DAX Studio and Tabular Editor, to mention a few. And depending on the tool, there are varieties of what kind of things can you do to the semantic model, depending what capabilities are built in there. But it's kind of good to get a view of what are the options available there. Getting to the last portion, I think I'm still right on time, about to finish off here. There is a few kind of reusable Power BI assets that can help with the report development. So there are Power BI templates as one option, and that is kind of a starting point that includes the report's layout, the data model, and it can include even some kind of query basis to get started with. And of course, any reusable assets always help with efficiency and consistency as well. And if you have an existing Power BIX file, you are able to export that into a Power BI template. And then kind of when you create a new report based off of that, then if there's any parameters, you are asked to put those in. Then the second thing that is mentioned in the requirements is a PBIDS file, which is a Power BI data source file, of course. And that really includes the connection details to kind of how are you pointing to the data source that you are trying to connect to. And if you have kind of many reports that you need to change the data connection to, this could be helpful in that context. One way is to author this from scratch, but you can also export it from an existing report file that has a connection to the right data source. That way it's easy to kind of get a good starting point. And then if you need to, you can further modify that using just any text editor that comes in handy. And then the last portion that has been added to this area is sharing semantic models. So you are able to take a semantic model and share it to other people so that others can take advantage of it. The point to note here is that you are essentially giving access to that semantic model. Sharing somehow sounds a little less than that, in my mind at least, but you are really giving access to that specific semantic model. And you can do this either from the semantic model or from the One Lake Data Hub, or I guess it's now called the catalog instead. And you are able to get the details page from there and share it from there. At that point, you get the option to put in a email, and then you can set, can they modify this onwards, share it, etc., as you are sharing that semantic model. So you have some control over what people can do once you share it on. That is the end of this section. This was all things deployment and making your life easier in that sense. And I will pass it back to Halil to pass it on to the next speaker as well.
Thanks a lot, Dani. I think up next we have Kevin.
Yeah, I was just getting used to watching everybody as well. You can all see my screen, hopefully, because I can see there's a nice orange glow. Right, now check 2. Let's check if PowerPoint's working. So this is me, by the way, folks, and I'll put my details in the chat to save me having to introduce myself. Just go and find me somewhere online. Anyway, so now we're going to cover prepare data. As you can see, it's a significant part of the exam, as Andy has already pointed out. And there's 3 main parts to it. And my clicker is going to wake up soon, hopefully. So get data, transform data, and query and analyze data. Strangely enough, a lot to do with data. So I'm just going to go through some quick points about some of the items now. So as far as how to create a data connection is concerned, you can use a data flows wizard, data pipelines, or notebooks. If I'm going too fast for anybody, feel free to say in the chat, by the way, and I will slow down. And hopefully the moderator will share some notes along the way here. And event streams, which is part of real-time intelligence, which was covered briefly during the introduction. So here's an example of one of the many ways you can get data. For example, if you're in data pipelines, you can take advantage of the Get Data Assistant, Copy Data Assistant even. I've got Get Data on the brain now. So as you can see from just this one simple example, there is already a large amount of sources that you can get here. And there's even more so by just selecting the different bullet points along the top. So some additional points to remember about this as well. On-premises data can be ingested for both data pipelines and data flows Gen 2. It does require the installation of the on-premises data gateway. So a bit like the diagram I've got here. So for example, you could extract data from a SQL database that then goes through a machine that's got the on-premises data gateway installed, which then will forward the data to somewhere in Fabric. Of course, it's a very simple overview. If you go online, you'll be able to view more in-depth information about this capability. And when you create new connections, they are managed in the Manage Gateways, Connections and Gateways menu item in Fabric. Now, if I do finally remember this, I will actually show it as part of the demo at the end of this particular section. So then, as Heini just talked about just now, actually, so you can discover data by using either the OneLake catalog, formerly known as the OneLake Data Hub. Probably a good idea to remember both, because sometimes when there's name changes, it can take a while for the changes to be reflected in the exam. And the real-time hub as well. So here's just to bulletize what I just mentioned for you all. And you can view both with using a high number of filters. And I will show you those very quickly now. We say quickly, and you've all seen this. This is Microsoft Fabric. When you first go into it, with the new and the improved icons for all the experiences. First of all, what I'll quickly show you, if you go to the settings in the top right hand corner, because I did say I would show this, you can select manage connections and gateways, and then from there manage your connections and those gateways I was talking about. So I'm just going to click on Power BI just to get the context items on the left to come to life. To access OneLake Hub, I click on OneLake icon on the top left, on the left hand side here. And as you can see, what was the OneLake Data Hub has been reimagined. And now you have this bit more user-friendly interface with more options now. Still do filter by keyword. You can nicely filter by types easily, and by domains, etc. as well. So there was a mention about domains earlier. You can do that here as well. For real-time intelligence objects, though, the real-time hub is now here. You may see I haven't got it here just yet. And that's because sometimes you will need to change your resolution for it to be fully visible. And again, you can just click on the left-hand side for it. So as you can see here, I can filter again by various items, etc. I can view for any particular Microsoft sources I've created, and for any Azure events as well. And as you can see, I've already got an Azure event here. So that was a very quick introduction to all of that. So now moving forwards, to ingest or access data as needed. As you can see, variety of ways to ingest different types of data, either through batch or time series data as well. In reality, you can kind of ingest batch in real time, but for the sake of this, I've split it into these nice two areas for you all. So as far as choosing between a lakehouse, warehouse, or event house is concerned, well, lakehouse is good, used typically working in a lakehouse paradigm, so storing the raw files and then translating them into nicely curated delta tables backed by Spark Compute. Warehouse is good if you want to use T-SQL to work with large volume of data in a relational manner. Now, I said T-SQL specifically. You can use Spark SQL when you're working with lakehouses as well, and bear that in mind when you're looking at all of this. Event house is really good for storing time series data, because then you can query it using the KQL language in a very powerful way. As some of you may have noticed in the chat earlier, somebody kind of had a spoiler anyway about the fact that Microsoft has a document for detailing which data store to use. As far as transforming data is concerned, it can be done in data warehouses, T-SQL. Can also be done with PySpark. You can use material views, etc., and functions when you're working in a event house. Just help with a bit of jargon here, by the way. Event house is a newer item that was created as part of real-time intelligence. It can host multiple KQL databases, and so it allows it to scale up, but all be nicely managed under one roof now. So when you think of the name event house, just think of one very nice roof, and that will help you remember its key purpose. So as far as transforming data again is concerned, for enriching it, adding new columns and tables, this can be done for delta tables and lake houses or data warehouse tables. So typically when you do this in a lakehouse, you would make a copy of the table into what's called a data frame. You can think of this essentially as a view behind the scenes for those of you with a SQL Server related background. Add a new column to your data frame and then overwrite the table. And a key point here, make sure you overwrite the table and the schema as well. Set the schema overwrite as well. And again, you can use the SQL syntax. So transforming the data. So as far as implementing a star schema is concerned, you can do this for a lakehouse or warehouse. Typically you do this with what's known as a star schema and not a snowflake. Now, just to help with a bit of terminology here, and I didn't have a very nice in-depth animation diagram for this for the benefit of time, but typically it's called a star schema because you have a fact table, and that fact table is linked to one or more dimension tables. And because of the pattern, if you've split these tables out, it's been called historically over the years a star schema. If you add additional dimensions, sub-dimensions within a dimension, then yeah, you would be looking more like a snowflake schema, as I say here. So typical examples include the AdventureWorks DW database to an extent, and also the sample data warehouse as well for the taxi rides. Bit of a tip here to get yourself used to the mindset of working with a star schema. And this is the reason I didn't have to do the nice animated diagram for this, is because I'm showing a link to this post. This post actually has two very good links here, one to another nicely detailed article about star schemas and another one for the actual video to back it up. So as far as aggregating data is concerned, it can be done in a lakehouse using either PySpark or Spark SQL, as I mentioned earlier. So just to help with a bit of jargon here, in case any of these two are new to people. So PySpark is basically the version of Python that you write with the Spark compute, which acts a lakehouse essentially. And Spark SQL is, as you can probably imagine, working with the SQL language when you're working with the Spark compute. And it's slightly different, by the way, for those of you who've worked with T-SQL over the years, it's slightly different than T-SQL. For example, when you're working with T-SQL, you're probably used to using a select top to get the top number of rows back for something. When you're using with Spark SQL, you have to put a limit at the end. It's very useful fact to bear in mind there. Now, when you're working doing this in a data warehouse, of course, you would use T-SQL. And you can also do aggregations when you're working in an event house with KQL as well. So as far as merging and joining data is concerned, there are quite a few different ways. It's safe to say to do this within Fabric. In the context of this exam, though, you only have to focus on certain areas. So, for example, in Lakehouse, again, PySpark, Spark SQL, and again for data warehouse, T-SQL. But you can also do it, and I should have really put this here. You can also do it with visual queries for data warehouse as well. You can add reference data, the time series data as well to help do a merge. So, or you can merge two event data coming in from two lots of event streams together. So when you're working with event streams, which is the GUI-based way in KQL, you can actually do a lot of merges and joins there as well by adding lots of different items and objects, especially when they're using enhanced mode. And then from a data factory perspective, apart from having a little bit of a typo here, apparently, you can also merge using data flows Gen 2. And here's a bit of an example here of how you can perform the merges. So natively, when you're working in data flows Gen 2, as you can see, you can go to do a merge here. You can select your join types. Those of you with a SQL related background will probably recognize these join types as well. So you're noticing a bit of a familiar theme here. So when you go to identify and resolve duplicate data, you can use the native languages, obviously in slightly different ways. I do, by my own admission, I like doing the duplication with PySpark because I find it quite performant actually using the dedupe syntax in there. So it is worth testing, finding online and testing that syntax, to be honest with you. It's very high performant compared to other ways of doing it in the lakehouse. So in the data warehouses, obviously you can use T-SQL, as you've done over the years, using a variety of different Transact SQL syntax. And in event streams, not sure why it says time series data there, but yeah, you can do it by filtering in the event stream as well. So as far as converting column data types are concerned, it can be done in notebooks with PySpark, and you can at times, by my own admission. Sometimes you have to put a bit more work in to do the conversion of data types when you're working with Spark in general. However, it is possible. However, it can be achieved easily with data flows Gen 2 as well, depending on your destination. So there's two ways I want you all to think about there for the converting of column data types. Predominantly at the moment, when you're working with lake houses, especially using PySpark, but you can also achieve the same with data flows Gen 2. Now, as far as filtering data is concerned, and obviously I'm cherry picking options here to an extent because there are other options included. So filtering data, again, it's a very common theme, as you can see here, using the native languages for data warehouses as well, though. You can also use visual queries to do the filtering. And again, if you're doing the filtering for the ingestion, you can do transformations, you can do it with data flows Gen 2. So here is one of multiple ways you can filter if you're using data flows Gen 2. And I know at least one Power Query expert watching at the moment is looking and checking to make sure I'm saying the right facts here. So you can do it one way very quickly and directly by clicking on a column. You can also select the item to do more advanced filtering as well and more advanced options. So I wanted to highlight that here. So finally, I've got a few split seconds left. I will very quickly show you how to do this using SQL and very quickly. Time permitting, I can run them for a few seconds over. So I will very quickly show you all now. I won't go too much in depth on this, but I will highlight the fact if you are, I'll make the resolution bigger for everybody. So this is just to give you an example of using T-SQL within a data warehouse. Like I say, it will be very quick because I am aware that I have to make sure the next speaker has enough time to speak. And this is a very quick introduction to visual queries, and it is literally a case that you can drag and drop additional tables, etc. on there if needed as well. So I just really wanted to very quickly show that there. I have to make the resolution a bit smaller a minute and get the landscape back here. I need to refresh my screen a minute because changing the resolution has changed that. There are some options I did want to highlight when working with visual queries to show just how similar it is to working with in Power Query, basically regular Power Query you may have worked with over the years. So I just want to show you all that here. You do have some options which can enable depending on what you're working with for viewing things like your column profile, quality details, etc. Just a little bit of advice for you all there. So I will very quickly go to KQL. Obviously, this is a very fast version of these demos. Just really wanted to open up When you work with KQL data, the best, most efficient way is to do it within a KQL query set for a lot of reasons. I will highlight here, yes, you can if you want to use regular SQL, but it's far higher performant to use KQL. And as you can see here, there's multiple ways I can summarize to do aggregations, project to filter out certain columns and options, etc. I mean, this is a very, very quick version of this demo. In reality, I could spend a long time on this. However, we do have more speakers to come. So key takeaways from this section. Workloads. Andy's already gone through the core workloads already. So data engineering, data warehouse, real-time intelligence, and you have to have some knowledge overall about the Fabric environment. Anyway, that's what from me, everybody. Do you appreciate this? Is a very short burst of information, a lot of information, short amount of time. And I did live demos, as somebody pointed out. So, and as I joked about with people the other day, I could speak about this section alone for hours, but I can't. Time is restricted. Over to the next speaker.
Okay, thanks a lot, Kevin. I think, Nicola, you have to talk as fast as you can. I don't know.
I'll do my best, I promise. So let me share my screen and then let's jump straight into it. The last part and the final part of the exam is implementing and managing semantic models. So it takes, same as the first part that Will and Heine introduced, it takes 25 to 30% of the exam. So it's still like a significant portion, but lower in percentage than the one that Kevin just presented. First of all, thanks Halil for inviting me, and I also enjoyed the previous part of the session and all of our friends and fabricators what they shown us. So let's jump straight into the action, since we have to cover a lot of things in this limited amount of time. So two main subtopics or skills measured within this part of implementing and managing semantic models are designing and building semantic models and optimizing enterprise scale semantic models. I won't go through this list and read all the bullet points because I assume you will get the access to slides so you can do it on your own. So let's use this time wisely and try to cover as many of these skills as possible. First of all, it's about choosing the proper storage mode for your semantic models. Before Fabric, let me just quickly remind you, we had to choose between two main storage mode options. The first one, the default one, is import mode. And I sincerely hope that you were using and you are still using import mode as your default choice. So with import mode, basically what's happening, we are creating a copy of the data from the data source, and we are storing the copy of the data in Power BI's internal database, which is called Vertipack. And then Power BI sends DAX queries and queries this snapshot of the data that we created within the Vertipack database. The main benefit of import mode is probably for all of you who at least once created a Power BI report in import mode over huge amounts of data. We are not talking about few thousands of records, because this is not relevant for measuring difference in performance. But whoever worked with larger amounts of data can testify that it's super fast. Of course, depending on different things, but the main benefit of using import mode is having a blazing fast performance. But we have two problems, or let's say two challenges when working with import mode models, and those two are data duplication and data latency. Data duplication, because essentially we are creating another physical copy of the data that already exists in the data source. That's the part in the middle. And data latency, meaning once you create a snapshot of the data within Power BI's database, until you refresh this snapshot of the data, you are working with the data that potentially can be stale. Meaning if something changed in the data source and you didn't refresh your import mode semantic model, you don't have, or your Power BI reports will not retrieve this latest data from the data source. And then the other option was direct query, which did exactly the opposite things compared to import mode. So with direct query, no data is stored within Power BI semantic model. It's just a metadata, so information about the tables, columns, data types, and so on. But the real data is stored and it stays in data source, and data stays in the data source before, during, and after the query execution. So whenever your Power BI visual needs data, it will go directly to a data source and pull this data out from there and load it into your visual. So direct query resolves these two challenges that import mode introduced, because there is no data duplication, there is no data latency. So since we mentioned that the data is retrieved at the query time, whatever is stored at the query time in your data source will be displayed in Power BI report. There is no data duplication. Again, no physical data is being moved and stored in Power BI's database. But I think we can all agree, whoever worked at least once with direct query or on, let's say, more than 1 million rows of data, that performance is significantly worse than with the import mode. So that was the situation before Fabric. And before we jump in to explain the new mode that was introduced with Fabric, I just want to stress that import mode and direct query are still here. So they're here to stay, meaning with introduction of Fabric doesn't mean that we don't use import and direct query storage modes anymore. On the opposite, but that's another story. I just wanted you to keep in mind that still import mode and direct query are relevant in times of Fabric. But as I mentioned, Fabric introduced this new storage mode, which is called Direct Lake. And this is something completely new in the data world, let alone in Power BI. So what Direct Lake tries to do is to exploit all the benefits from both import and direct query storage modes and pack this in this under this umbrella of which is called Direct Lake. So the same as with direct query, data stays in its original data source. In this case, those are delta tables in one lake in Microsoft Fabric. So data is loaded on demand, meaning whenever your visuals from the Power BI report need certain data, Power BI will go directly to one lake and pull this data from delta tables which are stored in your one lake. And this data will be then imported into a Vertipack database on demand. So when your query needs certain data, this data will be loaded on demand in Vertipack database. And that's why we consider Direct Lake as a mix of import mode and direct query, because it works to some extent the same as import mode. Once the data is loaded into Vertipack database, it behaves exactly the same as with import mode. Whereas on the other side, we still have our data stored in our data source, so we don't have data latency, we don't have data duplication, so we get all these good things from direct query storage mode. It is a revolutionary feature. Whatever you hear people telling, it is something really brand new that didn't exist previously, but there are certain prerequisites for Direct Lake to keep in mind. First of all, you need either Fabric F capacity or Power BI Premium or P capacity. Then you need a Lakehouse with SQL endpoint for direct query fallback or warehouse. So Direct Lake works with both Lakehouse and warehouse. Data must be stored in Delta format. So if you have your data stored in any other format than Delta, then no Direct Lake is possible. And then there is a V ordering, which is, I intentionally put this asterisk at the end because this is not a hard requirement, meaning even if your tables are not V ordered, Direct Lake will work, but you may experience a lower performance if your table are not V ordered. If you're wondering what is V ordering, without going deep into technical details, because it's not relevant for DP-600, it's just a Fabric specific way of additionally optimizing Parquet files when writing the data. So data is being reshuffled, sorted in a specific order so that then data reading operations are faster and more efficient. Of course, this is a new feature and still a lot of limitations apply. Be aware of these limitations, especially from the perspective of DP-600. If you have a case study and then you need to propose the best possible storage mode for semantic models, some of these limitations may affect correct answer. So first of all, you can query just one single lakehouse or warehouse. Then T-SQL views are not supported, or to be more precise, they are supported. You can use them in direct lake models, but all the queries that get the data from T-SQL views will automatically fall back to direct query. So it's not pure direct lake. Then there are certain guardrails. We can maybe share the link later where when your DAX queries are exceeding those limits based on your capacity size, then when you hit those limits, your queries will automatically fall back to direct query mode. No DAX calculated columns. I know we shouldn't use them extensively, but still I know there are a lot of semantic models with DAX calculated columns. These are not supported in direct lake scenarios. No composite models and no relationships on date time data type columns. So date is supported, date time is not supported for relationships. And again, here is the link just for your for you to check always the list of current limitations, because things are changing rapidly in Fabric world, so direct lake is not an exception. Then let's talk about relationships. That's one of the key concepts in data modeling. And unlike in traditional relational database scenarios, when we cared only about the cardinality of our relationships, in Power BI semantic models, relationships also serve as filters between the tables when we are executing DAX calculation. So let's first examine the concept of relationship cardinality. And there are 4 possible options to choose from: one-to-many, many-to-one, one-to-one, and many-to-many. So I'll give you a simple example of one-to-many or many-to-one relationship in a semantic model. In this case, I have 2 tables, product and sales. There is a product key column in both tables, and then we create a relationship between 2 tables on that common column. However, since the product key in the product table contains unique values, if we define a relationship from this column to the product key column in the sales table, this will be one-to-many relationship. If we do the opposite, it's going to be many-to-one relationship. So one-to-many and many-to-one is basically the same. It's just about in which direction relationship goes. One-to-one, I'll skip this because this is usually, in most cases, sign of a suboptimal data model design, and it should be implemented really as an exception in your data model. So let's jump into explaining many-to-many relationships. Also, they are considered as exceptions rather than the rule, but still they have like more use cases than one-to-one relationships. And there are certain scenarios when this makes sense, such as connecting fact tables with different grain or connecting many-to-many dimensions, for example. Like in this case, I have an example of a model that contains 2 tables, customer and account. One customer can have multiple accounts. Also, one account can be shared by multiple customers. In this scenario, a recommended practice is to create a so-called bridge table, which stores unique combination of each customer and account. And then we create 2 regular one-to-many relationships between our dimension tables and the bridge table that we created in the middle. Another important concept when designing relationships is filter direction. And there are 2 possible options with filter directions in relationships. Single direction, which is a recommended practice and should be used whenever possible, and bidirectional or both directions. Again, this option has its use cases. I won't say don't use it never ever, but should be implemented with special care. The arrow on the relationship reveals the filter direction. In this case, we are talking about a single filter direction going from the product category table, then to the product table, and then all the way to the sales table. This means we can filter values in product and sales tables by selecting a value in the product category table, but not the other way around, okay? On the other hand, if I go and set my filter direction to both, in this case, the filter can be propagated in both directions, meaning I can select something from my sales table, and this selection will be propagated, and my product and product category table will be also filtered. Again, I would like to emphasize that you should use bidirectional filters with special care, and if you need for certain calculations to implement a solution that leverages bidirectional filtering, there is a solution which is called cross-filter function index. So if you get a question in your DP-600 exam, how you can overcome a limitation of using bidirectional relationship and activate bidirectional filtering just for specific calculations, cross-filter function index is your best friend. Let's examine few more groups of functions, DEX functions that are relevant for DP-600 exam. First is iterator functions. So as their name suggests, they iterate over a table. And then the expression that you define within the function is evaluated for each row. And then finally, we are aggregating results. You can easily recognize those iterator functions. They all end with X. So compared to their regular aggregator function relatives like average, count, mean, max, and so on, these one are called average X, sum X, count X, and so on and so on. In the end, why it is important to understand iterator functions when you write an expression that says total sales equals sum over a single column, this will be internally translated to the expression that you see at the bottom. So essentially, this one is translated to sum X and then table as the first argument and column or expression that you want to evaluate as the second argument. Whenever you are using more than one column in the expression, that is important to remember. Whenever you use more than one column in the expression, for example, you are calculating total revenue by multiplying unit price with quantity sold, you must use iterators. So you can't use aggregator functions on more than one column. So in those cases, you have to use iterator functions. The next group is window functions. If you're coming from the SQL world, you might have already heard about window functions, but this is a relatively new enhancement in the DEX language. And similar to SQL, they aim to provide the possibility to calculate specific expressions over a sorted and partition set of rows. Three main functions are index, offset, and window functions. And by leveraging these functions, you can easily calculate something like sorting customers by total amount spent, compare the sales from the current and previous year, or calculating moving averages or running totals in the window of n quarters, months, days, whatever. When you use window functions, it's important to understand their arguments, order by and partition by. Partition by determines the window itself, or simply said, the subset of rows that we want to apply our calculation on, whereas order by defines the sorting order of the results within that subset of rows, within the partition. Let's first introduce the index function. This function simply returns a particular row of the table based on its position. In this case, if you want to return the brand with the highest sales, you can use the index function and then specify number one for the best performing brand. In combination with partition by clause, this means that we performed our calculation on a table that is now split into multiple smaller subsets of rows. So let's imagine that we want to identify the highest selling brand within each category. So not the overall highest selling brand like we did in previous case. Now with partition by clause, we can split our main table into multiple smaller tables. So each category will be a window on its own, will be a small table inside a table, and then we perform our calculation just on this specific partition. Offset function it's very simple. It returns the value from the cell which is before or after the cell that is being currently evaluated in the context. In this case, with -1, we are returning the value from the previous cell. In case I switch this to -2, then it goes 2 cells before, and so on. Window function is probably the most complex one. It enables to define the window based on the current row using either relative or absolute references. Again, let's explain this on an example. It's much easier to understand. So I'm analyzing 2 customers here from the AdventureWorks dataset, Adam Young and Alexander Jenkins. And here is the summary of their orders and total sales amount. The first concept to understand here is that we want to treat each customer as a separate entity, meaning we want to create a window for each customer and then analyze figures for that specific set of rows. In this case, I have 2 windows. My window number 1 is Adam Young customer. My window number 2 is Alexander Jenkins customer. Now, window functions index can work in 2 different ways, either operating on a relative value based on the current row or by operating on an absolute value. In my case, I always want my window to start at the first row of the partition, meaning each customer, the first row for each customer, and finish on the last row of the partition. So this is the measure that creates a calculation that will go over and calculate total sales amount for each customer based on the partitioning that I did here as a customer. And finally, group of DAX functions are called information functions. We can split them into main subgroups. So the first one is the group that returns info about data type or filter context. There are many of them, but some of most commonly used are contain string, which evaluates to true if, for example, if you're searching for a product color and that equals blue, it will return true for whenever you find a value, whenever it finds a value blue within the product color column, or has one value which checks the filter context and it evaluates to true if there is only one value in the specified column. We have also recently introduced group of info functions which start with info point and then something. So these functions return very useful information about your semantic model. So with info.tables, info.columns, you can get information about your semantic model and its core elements such as tables, columns, measures, calculation groups, hierarchies, and many, many more. I just put here a few of them, but there are more than 25 of these info functions. Okay, so now few advanced features, or let's call them advanced features for semantic models in Power BI. I'll start with calculation groups. And instead of giving you a dry definition of the calculation group, I'll try to share a descriptive version. Imagine that you have a fact table that contains 10 different metrics. For example, sales amount, sales quantity, discount amount, return quantity, and so on. And as every professional Power BI developer, you will go and create 10 explicit measures for each of these metrics, right? So the next step is to provide your business users with additional information. For example, what was my sales amount in the previous quarter? Or how was my sales quantity developed year over year? Or what is the running total of the return quantity for the selected time period? So how do you achieve this? Of course, you go and write a measure to calculate the sales amount for the previous month, the sales amount for the previous quarter, the sales amount for the previous year. Then you write the same set of calculations for sales quantity, then for return quantity, and so on and so on. So you quickly end up with 50 measures in your semantic model. And most of them essentially contain redundant logic. You're just copy pasting the expression and then you just switch the base measure. And here calculation groups come to the rescue. With calculation group, you set the placeholder for the specific base measure, like for example, sales amount or sales quantity. And then you define a set of calculation items that will be applied to that placeholder measure. placeholder measure is defined by using this selected measure function, and this function evaluates whatever measure is currently in the context. It can be sales amount, it can be sales quantity, and so on. And then we have calculation items for the measure in the context. In this case, I've created two calculation items, one for month-to-date calculation, which is on your right, and another one, year-to-date calculation, which is on your left. And the only difference is the calculate filter modifier. There are no two separate measures anymore. It's just a single base measure in the scope. In this case, let's think about it as sales amount measure. Then another cool feature in Power BI is called field parameters. In a nutshell, field parameters enable you to perform two actions. First, you can dynamically change the attribute for slicing and dicing the data in the visual, meaning dynamically switch between different columns, or dynamically change the metrics displayed in the visual, meaning dynamically switch between different measures. And I can hear you, Nicola, we could have done this before field parameters as well. That's true, but instead of using DAX complex logic, using tree test functions, or I don't know, whatever we used before, or playing around with bookmarks, now you can set everything up without writing a single line of DAX code in just a few clicks. Okay, so that's the power of field parameters. Next topic is dealing with large semantic models in Power BI, and there is a setting in for your semantic model which is called enable large semantic model storage format. Before you do that, I just want to drag your attention to how you should structure your semantic models in Power BI. So we have two main groups of tables, let's say type of tables in semantic models. We have a tall table with many rows and less columns. That's usually a fact table in our star schema semantic model. And we have wide tables with many columns and less rows. Those are usually dimension tables in our star schema. I intentionally use word usually because there are some exceptions here and there, but in most cases, when we think about dimension tables, we are thinking about wide tables with not so many rows, and fact tables with many rows, potentially millions, billions, and so on, and not so many columns as dimension tables. So those two scenarios are completely fine from the perspective of modeling your data in Power BI. What is not good is if you combine those two, if you have a tall and wide table with many rows and many columns. You probably heard about one big table approach or one flat table approach. This is not an issue from performance perspective if you don't have too many rows, but try to use multi-million fact table with many columns without splitting that into dimensions, and you will probably hit performance issues, let alone another problems that this approach can cause. What this enabled large semantic model format allows you to do is to overcome the default limitation of 10 gigabytes of your semantic model size in a workspace. So essentially, it allows you to scale your semantic models up to the maximum size of your capacity. So if you're using, for example, P3, which is an equivalent to F256, it has a maximum limit of 100 gigabyte per semantic model size. So in theory, your semantic model can be up to 100 gigabyte in size. Of course, depends on other things, but keep in mind that when you enable large semantic model storage mode, it allows you to scale your individual semantic model up to the maximum size of your capacity. Composite models is another component that you need to learn for DP-600. Composite models, meaning we are combining two or more different direct query sources, or we are combining one or more direct query sources and import mode sources. How this looks in reality, all imported data is considered as one source group. So it doesn't matter if you have data coming from Excel files, SharePoint lists, SQL Server database. Once you import this data into Power BI, that's one source group. And then we have different direct query data sources, and you can combine data from these different sources within a single semantic model. The problem or the challenge with combining data from different source groups, meaning import and direct query, is that you will end up with limited relationships. Obviously, this is out of the scope of explaining the downsides of limited relationships in this session, but keep in mind that you want to avoid that in general, and that's why we are taking care of this issue by using aggregations. Aggregations is another built-in performance optimization feature within Power BI. The overall idea is obviously to reduce the amount of data for working with when working with Power BI reports, and you need to make Power BI aware of these aggregated tables. This slide is super important because I'm pretty sure you will get a question that will ask you to provide the most efficient way of setting the storage mode in your composite model with aggregations. And that's why I want you to remember what's written on this slide. So when you are creating aggregations in composite model, the original table must be direct query. So if it's not direct query, no aggregations are available. So it must be direct query. Dimension tables, you can set whatever storage mode you want, but with dual storage mode, you overcome the limitation of limited relationships. That's why you want to set dual storage mode for your dimension tables. And finally, your aggregated tables can be in theory in direct query, but the maximum performance is achieved when you set storage mode for your aggregated tables to import. So please keep in mind those three recommendations when setting aggregations. And the other is smaller subset of topics, optimizing enterprise scale semantic models. So we created a semantic model. Now we need to make them more efficient. And in the end, there is a huge difference. I always like to say this. There is a huge difference between the report that just works and report that works efficiently. So how do you define where the problem is, or how do you troubleshoot your poorly performing Power BI solution? First, who complains about performance? If it's a DBA, then probably your issues are lying somewhere in the background. So it's either data model size or data refresh process is not running efficiently. If it's an end user or report consumer, then probably again your issues are lying at the front end, meaning it's either your DAX measures or visuals rendering time. Now, the good news is that within Power BI Desktop, you have a built-in feature which is called Performance Analyzer. And this feature enables you to capture all the key metrics of the report performance. There are 3 of them. So let's go and see, because again, this one can easily be one of the questions at DP-600. First is DAX query. This means time needed to return query results after the DAX query execution. Then visual display, which represents the time elapsed for visual rendering. And the most tricky one is other. Other is means usually how long a specific visual had to wait for other processes and queries to complete. To give you a simple example, if you have a report page with 20 elements on that page, don't forget Formula Engine in DAX works in a single threaded way, so it can send just one DAX query at a time. So all of your 20 elements of the report page will execute in sequence. So the poor guy, which is last in the queue, the 20th one, needs to wait for those previous 19 elements to complete before its turn. So that means this other will represent the value in time, in milliseconds, how long this specific element had to wait for other processes on the report page to complete. General recommendation is, if you have multiple visuals on the report page and the page is slow, then reduce the number of visuals. So that's the first rule of thumb: fewer visuals on the page equals better performance. Then again, potential bottlenecks, it's either in visuals, so if you reduce the number of visuals, it will speed up the report and also remove the clutter from the report. If DAX query is the problem, then I don't have good news. You need to learn and understand DAX. So there is no shortcut to troubleshooting DAX queries. So you need to learn and understand DAX. But the good initial step is that you figure out that DAX is the problem for your poorly performing Power BI solution. Few more concepts that are relevant for this updated version of DP-600 is, first one is the concept of refreshing data in direct lake. This one is internally called as framing. So there is no data refresh as it is in import mode. We already mentioned that at the very beginning. So with import mode, when you refresh the data, literally physical data is being copied from your data source into Power BI semantic model. Here, no data is being copied into your Power BI semantic model, so it just contains metadata. It's empty, no real data is in it. But when you refresh data model, everything goes out of the memory, and then when user starts interacting with the report again, columns that are needed by the query will be loaded into memory. So it's just a metadata operation, and you will see if you try to refresh your direct lake semantic model, even though you have, I don't know, 500 million rows of data inside, it will take probably not more than 20-30 seconds, which is not the case with the import mode where you really load these 500 millions of rows. By default, this option, refresh option for semantic models, is turned on in your Fabric workspace. So that means if you don't turn it off, as it says here, Power BI will automatically try to detect all the changes in the underlying table and make synchronization between the data that is metadata that is in semantic model versus what you have in one lake. So this is turned on by default. If you want to handle this manually and take control of this process, you should turn off this option, keep your direct lake data up to date, and then handle this as part of your regular ETL process. Direct lake behavior property is the one that defines what happens when direct lake cannot be achieved within your semantic model. That means whenever you define whenever you configure a direct lake semantic model, and I already mentioned in one of the previous slides that by default all the queries that cannot execute as direct lake queries will fall back to direct query storage mode. With this property, direct lake behavior, you can control what happens in case that direct lake is not possible. So by default, again, if direct lake is not possible, your queries will be executed as direct query queries. If you set this property value to direct lake only, then whenever you hit any of the limits for your queries in direct lake mode, the query will throw an error, so it will return an error. And finally, direct query only means that no direct lake is happening. All your queries will be automatically sent and executed as direct query queries. One last topic. I know we are slightly over time, I apologize for this, but yeah, a lot of things to cover. Incremental refresh process. So this is a concept that exists outside of Power BI semantic models as well. The idea is, okay, you have some transactional database that stores the data from your application, and then you need to keep this data synchronized with your data warehouse as your single point of truth for business reporting. Now, what's the idea? If you go and pull all the data each and every time once you need to synchronize transactional database and your data warehouse, you will probably run into issues once the amount of data starts to grow. So what we are usually doing to avoid this time and resource consuming processes is basically we are defining a window. So if I refreshed my data yesterday at midnight, so I don't want to go and check all the data that was already inside the table. I just want to check the rows that came in the meantime. So after my last refresh process, and then instead of reading the entire table, I'm just reading a small portion, small chunk of this data, and this is usually way more efficient and performant. In Power BI, what happens is that by default, each table has or consists of just a single partition. So it doesn't matter if you have a table of 5 rows or 5 billion rows, this table contains just a single partition by default. And then we can define with incremental refresh, we can split this table into 2 partitions. One partition that contains archive data, so the data that doesn't change. And then we have a partition that checks for those rows that came in the meantime and update or insert this data into our semantic model. This is an illustration of how this incremental refresh workflow looks like in Power BI. So you see that real-time, what is a real-time data as of today, tomorrow or after the next cycle of incremental refresh will become incremental refresh data, and this data window moves as time passes by. This data moves, and this is so-called rolling window pattern. Some of the prerequisites for incremental refresh, this is important again from the perspective of DP-600. You need to have a date column in the table where you're defining incremental refresh policy, and this date column must be either date type or integer type. So Power BI is smart enough to figure out if you have an integer type for date column that to apply incremental refresh policies. Query folding must be happening. Again, one of the most important performance optimization features, query folding, because when you define date range parameters for incremental refresh, this must be translated to where clause in the SQL query. And it's allowed only for a single data source. So you can't define incremental refresh policies on data that is coming from multiple different data sources. That's it from my side. I'm sorry for going a little bit over time, but I hope it was useful and helpful for the exam.
Exactly. I don't know how I calculated time needed for each presenter, but each presenter did a great job. I'm very happy. This was supposed to be 1.5 hours. We're running over 2 hours now. But now, more fun part. Rishi, Abu, and I think, will present quizzes.
Cool. Hey, everyone.
Halil, can
so,
you make Rishi a presenter? I think he's asking.
Yeah.
Okay. Let me open these polls.
Yeah, we did 2 hours last time with DP-500, right, Andy and Nicola? So DP-600 is a much bigger syllabus, and yeah, I think we need 2.5 hours for this one, basically.
Yeah.
Right, brilliant. Okay, so we've got some polls and some quizzes. And yeah, Halil, could you just make the presenter and I'll share the questions.
Okay, do you see my screen, Rishi? Do I need to hit submit or?
Well, actually,
This
we could do it through the polls. I mean, I was going to share the screen and share the quiz questions on the screen, but it's fine if we've got them in the polls and people can read it. So, can everyone see the polls? So we've got the first question.
Yeah. Do you read the question or I read the question?
I can read it out, it's fine. Yep. So which of the following statements are true with respect to applying security for data warehousing? So we've got viewers with readable access can bypass object level security by accessing the data OneLake directly. A workspace member contributor role allows the user to see workspace scope sessions, monitor connections, requests, and DMVs. Microsoft Fabric item permissions enable the ability to provide use of SQL permissions without needing to grant those permissions within SQL. Workspace roles provide permissions for all warehouses within a workspace. When object level security presents unauthorized views. So at the moment, we've got a single select on these. I think actually we should be able to select multiple on these. Yes. I don't know if that was something you were able to do, but that's fine.
Would you like to choose, Nicola?
I guess we'll see which ones are most popular because there's multiple of these that are true. Yeah, it's not just one of these. These
Just to
multiple
add,
spots.
Rishi, I think Will showed that great slide,
Yeah.
you know, that covered all of these. And just in case somebody is like, nobody would remember all of that, which is there on that slide, you can always go to the Microsoft Learn documentation, provided you have the time, A, and B, you remember which link you need to go to. So you can always, you know, get a sneak peek into some of the hints that are there.
Yeah, absolutely. So I think we've got a few that are true there. So I think actually that might be worth just bringing up that link again. I'm still not able to share. Abby, are you able to share?
You're not able to share?
No.
So are these polls all single select in terms of the choices? Because we've got a couple of multiple choice questions here, multiple response questions where you can actually choose more than one option.
Rishi, currently you should be able to share your screen.
Now I can share, yeah. Okay, perfect. All right, so let's see if let's just go through these options. So we've got viewers with read-all access could bypass any object level security. What are we saying with that one generally? So let's just go through these quickly. So we've got most people have said, actually no one said yes to that, so we'll not click that one, but I think it is true. A workspace member contributor role allows the user to see workspace scope sessions. Potentially, but I think actually with this one you need an admin role to be able to actually monitor those DMVs. So I think that one's actually false, and this one's true. False. Microsoft Fabric item permissions enable the ability for user with SQL permissions. Yeah, absolutely. So you don't need to grant permission specifically within SQL. You have access to SQL endpoint through item permissions or workspace permissions, which give you access to the items. You can obviously then do row level security and object level security to grant specific permissions to users within those roles. And then workspace roles provide permissions for all warehouses. Yeah, by default, all the items within that workspace. And this one is false. So object level security prevents unauthorized viewing of rows and tables using familiar word clauses. So this is actually row level security. Yeah. So if we just go to these again, so viewers can, with read-all access, can bypass object level security. A workspace member contributor role, no, it needs an admin role. Item permissions, yes. Workspace roles, yes. And this is row level security, not object level security. So that's those are the ones that are true there. And again, this is the link. So I'll put this in the chat as well, so just so people can go back and see those. All right. Now, next question. Which of the following is typically a best practice for working in a multi-developer environment using source controllers such as Git? Do we, so this is single select, do we allow developers to check in directly to the main branch, get developers to create feature branches or workspaces and then merge the changes from the feature branch to collaboration branch? Or do we create all the feature branches up front and then have the central team merge the code from there into feature branches?
Halil, you need to put this in the chat as a poll.
Yeah. So if you just activate that poll, please, Halil.
Yeah.
I'm trying to do that, but it doesn't allow me.
Yeah, it's there now.
Watch the polls.
You've got a few options for choice B, then I think one option for choice A as well. Option A.
Yeah, so we've got A, B, or C. Yeah,
Yeah.
I mean, if you can't see the poll, you can always just write in the chat A, B, or C. We've got B there in the chat. And yeah, the most popular is B.
It's B.
93% so far saying B. Yeah, so we say that
correct.
it's correct. And again, we've got a link there to learn more. So next, we are using Power BI deployment pipelines, which share data sets, separate workspaces. What will happen to the connection between the reported data set as the reports are moved through the deployment pipeline? So will it auto bind? So if we have the report and data set connected separately, it will recognize this connection. Will it not automatically update? So the test report will still be bound to the development data set. Will it only auto bind across pipelines if the setting is enabled? Or will it auto bind if it's Fabric Power BI Premium for capacity, not Power BI Premium per user? Hopefully that question makes sense. Does anyone need any clarification on this idea of auto bind in the sense where you've got reports and data sets in different workspaces? We've only got one response on that one so far, but
Yeah.
that's fine. Should we just go with the one we've got?
I think just wait for a few more seconds. It's a long question.
It is a long question. Apologies. Yeah, I should pick some shorter questions for these. So in the quizzes that I've got, and actually, if anyone wants to try out some of the questions, I'll put the link in the chat for the Microsoft training website. That so I'm just looking for some volunteers actually to start to take some of these quizzes and provide some feedback. There are a lot more of the questions are actually, fill in the blanks and complete code blocks and things like that. So we've got more questions like that. Fewer questions on this, but yeah.
I think we have got maximum responses for B and C. Option B
Okay,
and C.
which one should we go
Yeah.
for then?
I think C are the
C.
most. Yeah, C.
So it needs to be enabled in the admin portal. So
No.
so we're actually saying it will automatically bind. Yeah, I don't think there is a setting for that in the admin portal to choose if it binds or not. So we've got auto binding in here. So auto binding across workspaces. So it says deployment pipelines automatically bind items that are connected across pipelines if they're in the same pipeline stage. So hopefully that answers that one. Yeah, it's a bit of a nuanced question, that one, around is it backed by AI, Kevin? What's the question there?
For the test questions that you're talking about, that you want people to go and test. Just
Is it
wonder if
backed
it's
by
backed
AI?
Yeah.
What, did we generate the questions using AI?
Well, no, not generate the questions, but based on the answers that individuals give to the different questions, is it intuitive enough to ask about, the future set of questions based on people's responses to the questions that are provided? We can take this offline afterwards.
Sure. Okay. So this is again multi-select. So we've got what types of data is real-time intelligence Fabric best suited for. So we've got time-based, streaming data, ledger balances, slowly changing dimensions, event logs, Internet of Things data, or semi-structured data, things like free text inputs on a website. So you can select as many as you want there. We've got lots of people saying A.
A, D, and E.
D and E.
A, D, E.
A, D, E. Okay. We've got some say A and E. And a couple. So nothing for B, nothing for C. And a couple for the free text input, semi-structured data. Okay. So actually, yeah, most of the part, but actually for semi-structured data as well, it's actually quite good. It doesn't need to be real time actually for using RTI. Actually, RTI is also quite good for things like this, for inputs on a website, for example, or text and semi-structured data as well. That actually is a good use case for that as well. Okay. Next question, what are shortcuts in OneLake? Is it a virtualization layer that allows you to access data in another workspace or environment in OneLake? Is it a way for you to upload files from your machine directly into OneLake? A way for you to chain data flows together? Or a way for you to write APIs to make your data available to other clouds or environments? We've got some B's and A's.
A.
Most people have answered A.
Most people have answered A.
Yeah.
Okay.
Because it's the longest answer. That's what Nicola said last year.
Yeah. Absolutely. So yeah, shortcuts in OneLake are this kind of virtualization layer. So you can connect using shortcuts into a different workspace, so data in a different workspace. Lakehouse, you can connect into Databricks, Synapse, data stored there, or even AWS or Google as well for OneLake shortcuts. Okay. So which of the following are advantages of using Parquet as a file format rather than, say, CSVs? So we've got, unlike CSVs, Parquets have the schema and data types embedded within them. B, Parquet files are the format supported by Delta Lake, which allows for transaction or data warehousing style capability to be used alongside the files. Parquet files have better compression of the data compared to Cs, quicker to load in Excel compared to CSV. So if you open a Parquet file in Excel, it's better to work with. And Parquet files are more universal data format across systems and applications compared to CSV. So multiple different systems and applications all read Parquet format or can export in Parquet format, for example. So let's see what we've got. Some multi-select here as well.
Yeah.
So most options we've got are B and C.
Yeah.
A little bit of A.
A, B, and C, mostly.
A, B, and C. Yeah. Are we good with those?
We've got around, yeah, I think B, someone has also said, a few people have said E as well.
Okay.
Yeah.
Interesting. So yeah, let's go for that. So yeah, absolutely. So Parquet files have schema embedded within them, and we can enforce that schema when writing to them. They're supported by Delta Lake. So this is the underlying architecture behind tables in the Lakehouse, which is Parquet format. So Delta has Parquet as its file format. A better compression of data. And this is what really allows it to be used in direct lake mode, because actually you get that same compression that you have in analysis services, we actually get with Delta format. And so Parquet files generally have the better compression. Quicker to load in Excel. You can't actually load Parquet files natively in Excel directly. Maybe you can, there's some add-ins to do it or something, but yeah, not natively. And a more universal data format. I think CSVs are generally more universal than Parquet as a file format in terms of things exporting and importing. Maybe things will move much more towards the Parquet format, but yeah, at the moment it's all very much still CSVs, I think. So yeah, I think that's right that we've got there as the main options. Okay, so we have this T-SQL query that calculates the average duration for each name in the dependencies table. So it says select name, average duration from dependencies, group by name. Which of the following queries is equivalent in KQL? So this is actually a single select. So it's only one option here.
One response. Two.
Okay, cool. So which one's the most popular? The first one?
Yeah.
Okay. So actually we've got, this is the second one that we've got. So we've got summarize average duration by name. So this one, it's KQL is case sensitive, so it's lowercase rather than uppercase. The other options use project. There's also one that's got equals average duration. So this is essentially a and this is project, it uses project rather than summarize. So it's actually supposed to be summarized. But also the other reason this one is not correct is because it uses an alias, which is perfectly valid, but there's no alias in the SQL. So if we had select name average duration as AVG duration, then you could use this syntax in KQL as well. Remember that you can actually use the explain function in KQL query editor to be able to actually essentially convert that SQL query into a KQL query. So it's got that kind of built-in intelligence in there as well. Actually as well, and there's a cheat sheet. Yeah, exactly. Thanks, Kevin. That's exactly what I was referring to there. Questions didn't have that in the poll. Okay, I'm not sure what the question is there. Okay, next question. We've got a couple more left. So which of the following might generally be considered a slowly changing dimension? So we've got employee location, employee date of birth, initial employee join date, and employee marital status. Again, it should be a multi-select.
A and D.
We've got responses are mostly for A and D, but some responses for C as well. Mostly it is A and D.
The marital status and location, yeah?
Yeah.
Okay. Yeah, Abby, do you want to explain this one?
Yeah, so this is the correct answer. So location marital status can potentially obviously change over time, and you therefore need to consider whether or not the data model should also contain the historical values. Whereas obviously the date of birth, it can't change, and the join date, if you're joining an organization, it will not change over time. So yes, so these are the two most likely candidates for having the SCD type 2 implemented, or as part of your star schema.
Yeah, so slowly changing dimensions. Yeah, I think Reza's got a good guide to it actually here as well. There's you can actually look up slowly changing dimensions on Wikipedia, and it gives a quite good description of it. But essentially, it's where you've got attributes that change over time, and some attributes change. And you need to make that decision. Do you care about just the latest value? In which case, you just put the latest value in, or do you want to track those changes? And there's multiple ways to do that. You could bring that into the fact table. You could have a separate table that essentially brings in the start date and end date, and then looks up on your fact table what your start date and end date was, and accordingly brings in the right value for that particular transaction. There's a few different ways to deal with it in Power BI and in your source data. It's generally something that you want to implement at your source data level. It's not something you can really implement in Power BI because Power BI is going to bring in your values, whereas you need to think about that in the table. So generally in your source tables, you might have and I think I put a link in this chat to this earlier, you might have a start date or end date against your columns, right? So it can say this attribute value is valid from this date to this date. And where it's the end date, you might put 31/12/9999 to show that it's still the latest one. So it's not ended yet. Whereas when that value changes, so it changes, say, on 26th of November, you'd put 26th of November as your end date, and then you used to put a new value with that date as the start date, and 31/12/9999 is your end date. That's typically the pattern that you would use to do that. Okay. Yeah, go.
Also, Rishi, there are multiple ways you can implement that. You know, you can use data flows, and you can also use T-SQL to implement this. You know, but whatever is your most preferred way. So it's an important topic. There is at least one question on slowly changing dimensions on the exam.
Yeah, absolutely. So which of the following two more questions left? So which of the following are limited relationships? So I think Nicola covered this briefly.
Yeah.
In here, so we've got a relationship between import and direct query. Again, multi-select, many to many between two import tables. A relationship that has bidirectional cross-filtering, and a relationship between two tables which is based on more than one column.
Your screen is still showing the previous question, Rishi, I think.
Is it?
Yeah, or is it me? I don't know.
It's showing the limited relationship.
No, it's me as well. We're still seeing the
still showing
answer
the
to
previous question.
one.
Yeah.
Slowly changing dimensions one, really? Okay.
Yeah.
That's strange.
Maybe stop and reshare your screen and see if that pops it back up. Is Rishi just frozen for everybody or just me?
For me
It's
as
the same
well.
for me as well.
Yeah, it is. He's frozen for I think everyone.
Should have the poll
everybody
up on
can
the screen. The poll up on the screen. You should see it.
Yeah. So the question is there, which of the following are the limited relationships? So we have got a few responses, and most of the responses I think are for A and option B. So let's wait for Rishi for a few seconds, and if he doesn't come, then I'll explain this.
I think it dropped completely.
Yeah. So most people have selected option A and option B, and these are the two correct choices. So a relationship between an import mode vertipacked and a direct query table. So this is a correct option, and a many to many relationship between two import mode tables vertipacked. So this topic was obviously covered by Nicola. I think he had a good slide on that. So you need to know which kind of relationship is a regular relationship and which one is a limited relationship. So yeah. So we have the last question, which is related to the DAX format function. So so you have to choose which DAX expression correctly you.
We lost Abu as well, I guess.
Uh-oh.
Okay, this is kind of question that I hate the most. Do you have to memorize something? I don't know what it is.
Was the last question the DAX expression?
Yeah, which DAX expression correctly uses the format function to display the number 1500 as double quotes 1.5k? Just please submit your votes.
Yeah, I think
I have
that
no
was
idea what the
that was the poll that was showed last.
Yeah, Rishi is in the chat, so when we say so, he can put the answer in the chat with his explanation. Oh, he's back. Let's vote for choice now.
Can you hear me, guys?
Yeah, we can hear you now. You're back.
Okay.
I just noticed
think
you
I-
at the corner of my eye moving again.
I think I dropped for maybe a few seconds. So yeah, this is something that like Halil said, it's hard to remember, but then obviously you have the option to go to Microsoft Learn and search for such answers if you are stuck somewhere. So always, you can skip this question and come back to it at the very end. So if you don't really know what is the correct syntax. So yeah, so let's see.
We need to repeat the thing.
So most people have gone with option A, and that is the correct result. That is the correct answer. So the format 1500, comma, and this format where you have the hash key, a hash sign, and then the 0 and the 0 is with a K. So that is the correct format for this kind of a question. I think we are done with all the questions, Ali.
Yeah, I think so. And Rishi is back. Let me.
Hey, hello.
Hi again,
Yeah.
Rishi. I think we have completed quiz.
Good. All right. Good. What did people get number 10 right? The format one.
Most people have some reservations about the last question, but that's how it is.
I was going to say that everybody got the answer straight away.
Well, actually, yeah, I can see 58% got A. So I mean, this comes into handy when you use dynamic format strings. So it's basically the same format strings that you use in Excel as well. And actually, that's how I tend to find those. It just put the number in Excel, format it how I want in Excel, because and it kind of writes the format string for you. Or you can use ChatGPT. And it does sometimes give you some weird results in ChatGPT when you ask for the format string. But it is a useful thing to be able to do. Like we use this, we do, for example, like income statements, for example, you want to have currency values and percentages in the same measure. So in some context, you want to show it as a number, and some context you want to show it as a percentage. So something like dynamic format strings is really useful there. And actually, in the same example, we use multi-currency. So if you've got Germany selected, you want to show it in euros. If you've got the American business unit selected, you want to show it in dollars. So actually, you could use dynamic format strings to be able to do that. Also useful for calculation groups, right? So you can do it as part of a format string in calculation groups as well, where depending on what you're showing as a measure, sometimes you might be showing it in different values or different. You might be showing a percentage as one output calculation item, and a currency against another. So those are the use cases, I think, for dynamic format strings. Bear in mind, if you use the format function to instead of dynamic format strings, it will basically convert it into text, which means you can't use it in visuals and things like that. So the format function's been a way to do it for a long time. It's just not the most efficient way to do it. So dynamic format strings is much better. All right, thank you very much. Apologies for the technical results. We didn't pass, we were close. It was 80%. Actually, I thought this pass mark was 70%, wasn't it, for the exam? So I think I need to update this to be passing score 70%. But yeah, we got 70%. So technically we did pass.
Yes.
I think with most practice exams, they aim for a higher percentage anyway, just to help everybody with the confidence before going into the exam. So you can keep it as it is.
Fair enough. There's different question types as well, and so we tried to pick just a multiple choice, a handful of multiple choice, and these things are quite hard to write questions for. And I've a lot of the questions I had were from last year, and when I was studying for the DP-600, which I took in February, most of the questions I actually wrote at that time when I was studying for it as a way to study for it, rather than just reading Microsoft Learn. So I've tried to keep them up to date, but it's been a real challenge given how much content's changed and how the nuances of everything in Fabric. So if you're interested in taking some others, there's about 250 questions in total across those 3 modules. So just fill in this quick form, and I'll give people access, and you can take some quizzes and let me know what you think, and then in a week or 2 I'll make it available to everyone anyway. I just want to iron out some teething issues with user workflows and get some feedback on some questions and stuff first. Great, thanks everyone. I will hand back over. Anything else from any of the presenters?
Anish, would you like to show the study guide?
Yeah. Let me. It's actually in the video. I've kind of highlighted it in the video there as well. There's an ebook that Abu put on LinkedIn. If you've seen a kind of data preparation guide with some exam notes, so we converted that into an ebook and put some material around like some interactive exercises and things like that in the ebook. Let me just go into it. I'll bring it up. I'll put it up in a few minutes, but I think I'll just hand over at the moment to Halil. But yeah, there's an ebook on there as well as a study guide.
Okay, thanks a lot, Rishi. As I said in the chat, these are the people that you have to follow, that you need to follow to learn more about Microsoft data related stuff. William has Fabric Dojo, which is an excellent place for learning Fabric related things. Andy, likewise. Kevin is like a god to me in terms of those things. In terms of CI/CD things, excellent sources, definitely. Everybody knows Nicola. He's the hardest working guy, I think, among us.
Yeah.
Okay. This was supposed to be only 1.5 hours. It's now almost 3 hours. Thanks a lot. It was a hell of a meetup. I owe you a lot. I'm really feeling like blessed. Thank you.
Thank you for coordinating, Halil.
Yeah.
Thank you. Thank you, everyone.
Thank you very much.
Take care.
Thanks all.
everyone.
Bye.
Oh, so there's her hand up with a question.